Welcome back. This time we're looking at linearity with multiple inputs. In the case of multiple inputs, the definition of linearity that I'll be using is y, the output, is equal to the sum over all of the inputs of a constant, I'll just call it c for now, multiplied by each of the inputs. That I would define as a linear function of the x inputs. In the case where you've only got two inputs, I could write that as y equals c1 x1 plus c2 x2, or as I've written it on the slide, a x1 plus b x2, where a is c1 and b is c2. Now this has the useful property that the effect of x1 on y plus the effect of x2 on y is the total effect on y when both x1 and x2 are there at the same time. That is the essence of what I mean by superposition. I could look at what the output is when x2 is 0. I'll call that y1. When x2 is 0, that would be just c1 x1. I could look at the effect on y when x1 is 0. I'll write that as y2. y2 is the value of the output y when x1 is 0, but x2 has a value. Well, that would be just c2 x2. If I add up these two contributions to y, I would end up with c1 x1 plus c2 x2, but that's just equal to y, the output when both of those inputs are present at the same time. This is the fundamental idea behind superposition. If we have a system with two inputs, then provided that system is linear, we can apply one input, measure the output, then apply the other input, measure the output, and then just add up those two output measurements, and that will tell us the output when both of the inputs are present at the same time. And it extends to any number of inputs, provided the system is linear. In contrast, however, supposing the system was not linear. Well, this is a system which is not linear, because we have a term here, c x1 times x2, which cannot be written in this format, a constant times one of the inputs. And if we see what happens when we try to apply this method to this system, well, if we set x2 to 0, then the output y would just be equal to a times x1. If x1 was 1, that would just be equal to a. If we set x1 to 0, then this term becomes 0, this term is still 0 because x1 is 0, we're just left with this term. And if x2 was 1, that would just be equal to b. However, if we let x1 be 1 and x2 be 1 at the same time, then the output would be a times 1, a, plus b times 1, b, plus c times 1, c. So the sum of the two outputs when only one of the inputs is not 0 is not equal to the total output when both of the inputs are not 0. As it says in big letters, in this case, for this nonlinear system, superposition doesn't work. It's important to be able to recognize when we can use superposition and when we cannot. So another set of 5 similar expressions, which one of these is linear? Again, if you like, pause the video for a while, have a think about it, and then restart. Okay, remember, for a linear system with multiple inputs, we need all of the terms to be of this form. A constant times one of the inputs. So the first one there, it's not linear because we have this term here, -3. You cannot write -3 in terms of a constant times one of the inputs. So this is not linear. We cannot use superposition with this. For example, supposing I set x2 equal to 0 and x1 equal to 1, I would end up with y equals 6 times 1 plus 2 times 0 plus 3, which is 9. I'll call that y1. Supposing I set x1 to 0 and x2 to 1, I would end up with 6 times 0 plus 2 times 1 plus 3, that's 5. Add up these two, and I would get 14. But the output when x1 is 1 and x2 is 1 would be 6 times 1 plus 2 times 1 plus 3, and that's 11. Doesn't work because we've got this constant term here, 3. Not linear. This one, however, is linear because we can write it in this format here. Superposition works. This one, not linear because we've got x1 squared. This one, yep, it's another one of my trick questions. Yes, it is linear. But in order to see that, you have to do a bit of algebra again. You have to multiply out these brackets, and that would give you 6 plus 3x1 plus 2x2 plus x1 x2 minus 6 minus x1 x2. The 6's would cancel, the x1 x2's would cancel. We're just left with y equals 3x1 plus 2x2. Yes, it's linear. You're not going to come across something like that very often. It's just there as a bit of fun. This one. Well, yes, that is linear. It's not a trick question. That one really is a simple example of a linear relationship between the two inputs x1 and x2 and y. So superposition would work for this function. That's all for this time. Next time, we're going to see how to apply these ideas to real circuits.